Hi there, Serdar Yagalop here for InfoWorld at IDG. In this episode of Smart Go, we're going to look at how you can write benchmarks to gauge the performance of your Go code. As with testing, which we covered in a previous video, Go's standard library includes tools for creating and running benchmarks, typically done side by side with your test suite. To demonstrate this, I'll pull out a new version of the code that I created in the last video. This is my two ways of computing a Fibonacci sequence. One uses machine native integers, and the other uses Go's math/big package. We have a test suite for this file, which should also look familiar, but in the test suite we now have some benchmark functions for the same code. Benchmarks in Go work roughly the same way tests do. We create a function with a name that starts with benchmark, notice the capital B, and then we follow that with another name that also starts with a capital letter. The benchmark function takes a single parameter of type testing.b and contains a loop which iterates b.n times. This is basically a mechanism by which Go's testing framework can run a function a number of times until its benchmarked statistics converge on a consistent enough range of results so that the outliers can be discarded. The contents of the loop are just the functions that you want to benchmark. Now, to run these benchmarks, we use the go test-bench command along with whatever files we want to run tests for. A dot in this case means we'll run everything. When we run the benchmarks, the benchmarking system first provides us with some stats about the system and the package that we're benchmarking, and then returns stats about the performance of each function that we've benchmarked. As you can see, the math/big version of our Fibonacci function is a lot less performant than the plain integer version. Each op in the integer version takes far less time to run, and so we can run many more rounds of the function in the allotted time. On the other hand, the big integer version doesn't cap out at the maximum size of a 64-bit integer, so there is that. Now, when you run benchmarks, you can also gather statistics about the performance of the program's CPU and memory usage, and save those to files for later analysis. To do this, we add some options to the go test command, including where to save our CPU and memory profile data. And once the benchmarking is done, we can analyze the data with the gotool pprof command and have a look at the details. And one small issue with the details I've just gathered here is that we have statistics for these two different function benchmarks all wadded up together. But we can run only specific benchmarks by telling the -bench switch which names of benchmarks to match. And so when we rerun our profiling to look only at the integer version of our function, we can see in the resulting profile a much cleaner breakdown. And as you can see from the breakdown, our program spends the vast majority of its time in the actual Fibonacci function. The remaining time is taken up with the overhead from the Go runtime or the overhead from the testing framework. So this is a reasonably efficient function. Now, if we run the benchmarks for the big integer version of this program and then inspect those results, we get a very different picture. You can see that the functions in the math.big package are taking up the vast majority of the time here. We are also spending a lot of time in the memory allocation and garbage collection parts of the runtime. So there may be some ways that we could perform further optimizations on this incarnation of the function, for instance, to find a way to do less thrashing with memory. Those are things that are going to be worth exploring in a future video, though. From here, you should get a basic idea of how benchmarking can work and go with just the tools that are available in the base library. That's it for this episode. If you liked it, please leave a comment below. Don't forget to subscribe to the IDG Tech Talk channel on YouTube. And for more Smart Go and more Dev with Serdar, be sure to follow me on Facebook, YouTube, and Infoworld.com.